Okay, ready for a deep dive? Today, we're all about linear equations.
Okay.
We're diving into this math textbook section 4, linear equations in two variables.pdf.
Oh, okay.
It's amazing how something as simple as a straight line can unpack these complex relationships. Yeah.
Yeah, it reminds me of this quote by Edmund Halley. He talked about using what he called analytic art to simplify problems using math, and linear equations are like the perfect example. They give us this framework to take these big, complicated situations and make them manageable.
I love that. It's like finding those first few puzzle pieces that suddenly make the whole picture clear.
Right.
Now, before we get into the world or two variables, let's rewind to those one variable linear equations. Things like, x plus 1 equals 0, just as a refresher.
Exactly. You got to solve for x, find that one solution, and bam! You can even picture it on a number line. Clean and simple.
Exactly. But it gets even more interesting, right, when we bring in a second variable.
For sure.
It's like adding another dimension to our math toolkit.
Definitely. It's like when you're analyzing a cricket match, say India versus Sri Lanka.
Okay.
And you want to understand what's influencing each team's score.
Yeah.
Linear equations with two variables can model that, represent the runs each batsman makes, you see.
Gotcha. So two Indian batsmen score 176 runs.
Right.
We could write that as x plus y equals 176, where x is the first batsman's runs and y is the second batsman's.
Precisely. Now we've moved past a single number line into this more intricate space where two variables are interacting. And this is where that standard form of a linear equation comes in. X plus b plus c equals 0.
Right. And the textbook mentions that a and b can't both be 0.
Yeah.
What's the deal with that? What happens if they are?
Well, if a and b were both 0, we just have c equals 0.
Huh.
That's not really a linear equation anymore. It's just telling us about c.
Ah.
We lose that link between the two variables, and that's what makes linear equations so powerful,
Right, so it's about keeping that two-dimensional depth.
Exactly.
We need both x and your really working in the equation.
Yeah, it means we're describing a line, a relationship, not just a single fixed point. And speaking of relationships, that's where things get really cool with linear equations and two variables.
Okay, so we've got our two variables, and they're playing in this two-dimensional space. What happens then?
Well, this is where two variables get really wild compared to just having one.
Oh.
With one, you got your one solution, your one spot on the number line. But with two, get ready for it, because we're talking infinite solutions.
Wait, how can an equation have, endless answers?
It's all about how x and y relate. Think back to the cricket thing, x plus y equals 176.
Yeah.
What we're saying is, those runs from batsman X plus the runs from Y, they got to equal 176. Lots of ways that can happen.
I guess, yeah. One batsman could get a century, the other one picks up the slack, or they both score in the 80s or something.
Exactly. And if we start trying out numbers, we can find even more. Say X is 20, plug that in, we get 20 plus Y equals 176. Right, so then Y is going to be 156. That's one solution. 20, 156.
Okay, keeping up so far. But how's it infinite?
The cool part is we can pick any X we want, plug it in, and boom, we get a Y that makes it work. X equals 50. Different Y, X equals 100. Another Y pops up and never ends.
Whoa, that's a lot of solutions. X and you are doing this dance, constantly adjusting to each other.
That's a great way to put it. And speaking of picturing this dance, there's no better way than with a graph. Remember how we said two variables is like adding a dimension? Now we see it.
The coordinate plane, with the x-axis and y-axis.
That's the one. And every single one of those infinite solutions, we can put it on the graph as a point. Simple example. X plus 2y equals 6.
Gotcha. Picturing it. Then what?
Let's plot a couple. If x equals 0, then y equals 3, right? So that's the point 0, 3. Then if x equals 2, you'd be 2, giving us 2, 2. Now connect the dots.
A straight line. So that's why they're called linear. They make lines.
You got it. And here's the kicker. Every single point on this line, even the ones we didn't calculate, they're all solutions to the equation. The line IS, the infinite solution set, visually.
That is so cool. It's like the line does all the work, showing us everything without us even needing to find each solution ourselves.
Exactly. And it gets even better when we bring this to real-life stuff.
Ooh, always love that. What's an example?
Think about force and acceleration in physics. F, SKX. You push a shopping cart, right? More force, faster it goes.
Yeah, like when I'm trying to get through the grocery store fast, more force, things speed up.
There you go. That whole more force, more acceleration thing, that's a line on a graph. Steeper the line, the stronger the link. The graph shows exactly how those two variables, force and acceleration, go together.
This is making so much sense now. But before we move on, what about those weird cases, like lines that are totally flat or straight up and down, those still have infinite solutions, right? So like every single line is infinite solutions. How do we actually use linear equations?
Yeah.
For real problems that have like one answer.
Ah, that's the clever bit. See, each equation, it's kind of like a rule X and you got to follow. Got multiple equations for saying X and you got to fit this rule and this one too, like adding extra conditions to a recipe.
So instead of one line with endless possibilities, we might have two lines, each with their own solutions. But it's where those lines cross, where they both agree. That's the important part, right?
You got it. That
Yeah.
intersection point, that's the solution that nails both equations at the same time. It's the sweet spot.
This is wild.
Yeah.
We went from a simple line to like multiple lines intersecting each one part of the problem. Like those 3D puzzles when it all clicks.
Perfect analogy. And that's linear equations power. They let us see A and D solve for those aha moments where everything lines up just right.
And to think, it all started with something as basic as a straight line. Lines are deep, man.
Right. It just goes to show even the simplest math stuff has hidden depths, tons of uses. Linear equations are everywhere. Physics, engineering, economics, even computer science.
It's true. The more you learn, the more you realize you don't know.
Yeah.
Every answer just brings up more questions.
Absolutely. So here's something to ponder. If one line is infinite possibilities, what could you unlock by exploring where multiple lines cross, each one a different side of your problem? The answers might surprise you.